You don't have your book. Let me show you where to find your book. Okay. So those are really good questions. So if you guys go into modules. So all the handouts that I'll be handing out will be up here. So your lecture notes will be up here. So just in case you weren't here for lecture notes, I'm only going to print enough for class. And then if you don't pick them up after a certain point, I'll toss them out. The lectures, all the lectures are going to be recorded. They're going to be posted up here when they're recorded and kind of cleaned up. And then if you go under course material down here, you'll notice there's a PDF with the book. What's that? It says it should be available to you guys. It's published. Let me take a look. That's been crazy. Hold on, give me 1 second. It's published, so it should be. So did you click the arrow next to it, or did you click the file itself? Yeah, because it's downloading from me, so it should be. No, not that part. This one down here. Over there. Oh. Yeah, that's weird. Okay, so I'll fix that problem. Okay. Okay, so I'll try to fix that problem so you'll have it available. If you go downstairs, Alyssa actually has flash drives that you guys can get that will have the book on it. Okay. As well, so. Okay, so we've already talked about scientific method. You guys, we've talked about machine in the corner. We have an idea of the observations that we can make. We start permanent questions. We do hypotheses. We do the experiments. We get our results, and we come to our conclusion. Right? And then if our hypothesis turns out not to be the case, we go through that cycle again. If it tends to work out, we finish with that conclusion and we publish a paper, and then we become famous. Or info. So you guys are very familiar with the hypothesis. So when you guys are thinking about some of the things that you guys are doing, think about what is the hypothesis that you're developing, right? So you guys are going to be doing an experiment in a couple of weeks, or actually next week, on scientific method. Some of you guys who did it this week, people online have done it this week. And so you formed your first hypothesis, right? And then after you try hypothesis, we go through and we set up our experiments to try to test that hypothesis because we want to determine whether or not it's correct. So this is going to lead us to sit there doing those experiments. We're going to get our results. And then if those happen to be true, then we start developing a theory, right? So theory is just basically, it's when you've already tested your hypothesis, you've found the experiments under those conditions that tend to make that hypothesis correct, right? And so it is established to be a theory at that point because you've done enough experiments to sit there and help figure things out. Then we get to the point of making it a law. Now, if we sit there and we've done those experiments enough, that theory then will become a law because it's held up to be true under all the circumstances of other people doing the same kind of experiments. Okay, so in chemistry, we have theories and we have laws, right? So that law is that next evolution of the theory if it continues to hold up. Have you guys heard of Einstein's theory of relativity? Or E equals mc squared, where energy equals mass times velocity. Nobody heard that? So we'll talk about it a little bit. Well, we'll talk about it here in a minute. I'll say it. Okay, so chemistry today. Now, if you guys are thinking about it, how many of you guys drove in today or this past day? Anybody drove to class today? Okay. Everybody? Good. So everybody drove to class today. Now, if you guys look to your left, you probably saw some fields, right? That have plants and everything growing in it, right? So if you guys ever thought about it, what's causing those things to grow? Water, dirt. Okay. What's that? Chemicals. Okay. What does the plant have to do to cause those things to grow? Because you can just put water and dirt. I can put water and dirt here. Am I going to get something growing? No. What was that? I'll need sunlight. Okay. So we get some sunlight from here. Okay, but I put water and dirt and everything, are we going to have anything growing here? We need a plant. And then what does that plant do with that water, that dirt, that sunlight, the chemicals? They absorb it. Okay, and so then what does it do with it? It grows. It just magically grows. Hey, I'm gonna grow. I gotta keep it in good. I'm sure. What was that? Okay, so it absorbs it. Yes, it comes in. But what is it doing with it? Have you ever thought, what is it doing with it specifically? It's eating it. Oh, okay. So it's eating it, kind of like you eat a pizza, right? Is that a chemical reaction? Okay, so what we're going to talk about are what chemical reactions. That is correct. That is a chemical reaction. The fact that you eat something and digest it, that's chemistry, right? So you wake up in the morning doing chemistry. I know it's amazing. Have you woke up this morning to eat? No? Well, we're starting right now, huh? Oh, don't worry about it. We'll be starting in 15 minutes after we really get started. We're going to talk about food a lot. So, how many of you guys cook? Okay, you're telling me that only 3 of you guys cook in this class. How are you going to live by yourself if you don't know how to cook? Okay, so we're going to TikTok the meal, we're going to YouTube the meal. Okay, y'all go ahead, do that. We'll see how well it works out. Because I see some of the things that they try to cook on. Well, it looks beautiful at the end, but they don't tell you all the times that that's good, right? So, anyway, you need to learn. Learn from your mom, learn from your dad, learn to cook before you eat. Okay, so now if you guys cook, anybody cook a cake? A box cake. We'll make it simple. We won't make it hard. Okay, make it quickly, make from a box. You like that? Okay. Well, part of your experience this semester, I want a cake every week. So we'll get a list of everybody who's never cooked before. You guys are gonna be making cakes. That's what we're gonna break you off. Okay? Pick your favorite flavor. We'll figure them out, right? So if you haven't cooked, you bring in your favorite flavor, we're gonna eat your cake. And we're gonna criticize it too, right? It's gonna be either good or it's gonna be like a hot mess. Okay? Deal? Okay. So, if you've ever cooked, I'm going to use the board a little bit. You'll see me running across here, pressing buttons. If you've ever cooked a cake, what are the ingredients?
Eggs.
Eggs.
Milk. Flour.
Butter. We have milk. We have butter. Ooh, somebody really knows how to make cake. They use real butter instead of vegetable oil. I like you already. Okay, and then we're making a box cake, so we don't have to worry about the flour and sugar and all that stuff. We're gonna keep it simple, right? So we also have 1 box of cake mix. Okay, so how many eggs do you guys use typically?
Like
I think it's 3. You have us, okay, she's gonna make the first cake. Okay? Next week, we're expecting a cake. Okay, how much milk do you typically use? Cup and a half? And then how many sticks of butter? Let's be conservative, and we'll just say 1 stick of butter. That's typically is anywhere from 3/4 to a stick. And I like mine buttery. Butter makes everything taste better. Okay, so now I want you to think about this. Now, when you're making that cake, what do? I combine my ingredients. Put them in my bowl, I whip it up, right? And then I do what? I put it in the pan, okay, got it in my pan, and then I put it in the oven. So when I put it in the oven and it's done, I take it out. Hopefully I didn't burn it, right? Flop it out. Oh, it smells so good. Is it the same thing that I put in? No. Can I separate those things? No, I can't. So once I do it, I can't separate it, right? So the fact that I put it in and it all became a single cake. Something that I can't break down or separate, that tells me that this is a chemical reaction. I can't get back what I started. That is a chemical reaction. Okay? So we have chemistry around us all the time, whether we recognize it as chemistry or not. Every time that you eat, chemistry is involved in that process. Do you guys eat raw chicken? Anybody eat raw chicken? No. What do we do to that chicken? We grill it, we fry it, we bake it, right? If you looked at the color of it, did it change? That's an example of a chemical reaction. So we have chemistry around us, so we need to start incorporating that in our lives, recognizing for what it is. It's chemistry, right? It'll make your life so much easier, and you'll like this class so much more. Okay? Plus, we get some cake next week. What's your favorite flavor? Vanilla? Okay, so we're expecting a vanilla cake next week. You guys hold her to it, right? Text her, let her know, hey, we're expecting that cake. So, you're going to see chemistry in all industries, from cooking to engineering to mechanic. You're going to always see chemistry, but a lot of people don't recognize this as that. And so we play a huge part as chemists. And a lot of things that we don't even recognize that we play a part in. It's at work now. Okay, so now I'm going to jump in with the numbers. We got to get that math part started. I know we've been kind of avoiding it a little bit. I'm going to give you guys some samples throughout the week. So the first thing that I want to start off with is scientific notation. Okay? So this is the format for scientific notation. That A dot B, C, D, 10 to the E. Okay? So what does that look like in terms of a real number? Let me write on the board and see if I can. So, an example. Can't make fun of my third grade handwriting too much. That's a decimal. Okay, 5.02 times 10 to the 15th. So that would be an example of scientific notation. where we have the number, one number, the decimal point, and then we have numbers following it, times 10 to the 15. That's letting me know that it's multiplied by 10 to the factor of 15. It's a really big number. I would love a paycheck like this. So waiting for it, okay? So that 10 to the exponential shown here, so that's gonna be our exponent. So that number represented here by E is gonna be your exponent. That tells you the factor that we're taking 10 to. Okay, we use scientific notation because we are going to be working with either things that are going to be really, really tiny or things that are going to be really, really big, right? And so we're going to need to be able to use that factorial. Otherwise, we're writing out numbers that are like pages long, right? And nobody wants to write all those zeros. Do you guys? No. Okay. Okay, so this is just a run through on how you would go about writing those numbers. I think the best way of doing it, rather than reading each of the steps, you can come back over it and read it separately, but rather than reading each of the steps, is to try to do an example, okay? And I know on your handouts, if you guys actually looked at your handouts, I actually give you the answer and everything like that, but try it without looking at the answers initially, and then go back and look at the answers, okay? Okay, so in this case, it says convert 3,672,199 to scientific notation. Okay, so the way that we're going to do this, we're going to start where the decimal would be at. Okay, so the decimal is going to be located right here. And then we're just going to move back. That's one spot, that's two spot, that's three spot, 4, 5, 6. So we're going to move so that we have only one number in front. So then we're going to write 3.672199 times, how many spots do we move back? Okay, so then we're going to put 6. Because this number is a big number, right? It's going to have a positive 6 associated with it. Okay, where if we look at the number below it, this guy's a small number. So we're going to go to the same point. We're going to start with the decimals at, then we're going to move back. That's 1, 2, 3. Oops, I got carried away. Yeah, 3. So we're going to move back 3. So then, in this case, it's going to be 4.61 times, so how far did we move back? 3. So then it'll be -3. Okay, so if we're moving this direction, we know it's going to be a positive number. If we're going to have to move back the other direction, we know that's going to be a negative. Does that make sense? Okay, so let's see. What if I gave you this number? Is that big enough? Can you guys see it? Or do I need to make it bigger? I see you squinting there, so that probably answers my question. Is that better? Okay. am I gonna do for this very first question? Where am I gonna start at? After 0, okay. And then I'm gonna move 2, 3, tell me when to stop. Till after what? Okay, right here? Okay, so then that's how many spots? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so then my answer is going to be
It's gonna be.
okay. And then for the one below it, what am I gonna do? Start at the decimal. Seven and 2, 7 and 0. Right here. Okay, so how many spots is that? So then it'd be 7 point 0.072 times 10 to the negative 6. Okay? Simple? Okay, great. Are you guys ready for the next one? Are there any questions so far? No questions? No concerns? Yes?
I think she really was, for the left, is it?
Say it one more time, please.
When it comes to like, this.
Yeah.
Is applied to the left.
Yes, so if you're moving this way, that's right. Yeah. Okay. So let's go ahead and convert 3.49 times 10 to the minus 11 to decimal form. So what am I going to do in this case? Since I'm working the opposite. We're going to do it backwards, right? So now I'm going to be moving this. Since it's negative, which way am I going to be moving? To my left. That is correct. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I put zeros in those points. Decimal right here. Right. And we always put a 0 there to remind us that that's a decimal right there. Okay, what about the second question? What am I going to do with that one? Just gonna go the other way, right? To the right. So, I'm gonna start with the decimal point. And then I'm gonna move to the right. 1, 2, 3, 4. So that's 51. Okay, piece of cake, right? Not too bad. Nobody want to jump bridges yet? Right, we're doing good. Okay, good. Let's move forward. Everybody got it down? I'll give you a second. You good? Okay, pull out your phones. I know you have them. So, if you guys go to your calculator, if you guys do me a favor and you turn your phones to the side, it becomes a scientific calculator. Can you guys identify EE? EE, or if you guys have Android, they use EXP, same concept. Or sometimes they'll say 10 to the X next to it. Okay, did you guys all find the EE? So then this is what I want you to do. We're going to put something in scientific notation. So we're writing 1.67 times 10 to the negative 25. Okay, so that's what we're going to try to put into our calculator. Now, the way that you do this, the EE represents 10 to the whatever it is. So the way that you would enter this into your calculator, you're going to enter it as 1.67 EE, that EE button, plus minus 25. Okay? Do you guys see that plus minus button? Sometimes on some calculators, they'll put just that minus in parentheses. That's the same thing as that plus minus button. Okay? So what happened? What did he give you? Did you guys hit, do me a favor, hit enter? What did it give you? Okay, so you got 1.67, and then it says E minus 25. So when it prints out this E minus 25, it means 10 to the negative 25, okay? So it's writing it as 10 to the negative 25. So this represents 10, or our base 10, okay? Okay, so this is what I want you guys to do. So you guys have just entered this number. Now I want you guys to divide it by 5.24 times 10 to the negative 50. Okay, so I want you to enter that in your calculator. Tell me what you guys get. And if you guys can just give me the first 3 digits, because it'll say a whole bunch of stuff. First three digits, and then give me. Okay, so what did you guys get? Yeah, 3.8, 3.18, 72, 70 times what? 824, so then that would mean what? What does that E represent again? It means times 10 to the 24 power. Okay? So, how many of you guys got 3.870? Probably a whole bunch of other numbers afterwards. Nobody got that? Or did everybody get that? We got one person. Anybody else having trouble? No, you didn't get that? Oh, you got it? Okay. How many people didn't get it? Because it's important that you get it. Because you need to be able to enter things in the calculator. If you don't get it now, it's gonna haunt you later. Okay, good. Own up. So you gotta let me know. I can't help you if you guys don't tell me. Thank you. Make it feel important now. So what you're gonna do is, you're gonna do it 1.67. Then press EE, and then we set to the negative plus or minus 2.5. No, just 2.5. Yeah, there we go. And then hit divide. Then press 5.24 EE, and then put plus or minus to the negative 50. So 50. 50. Press equal. Okay, so is that what you got? Same thing that they got. The 3.870 times 10 to the 24. Yeah. Okay. Did you get it? You got it? Good. Did you get it? Good. You did it on your computer? Where's your phone? Oh, you did it on your phone. So are you sure you got it? Okay. Are you losing your voice? You good? Okay. Everybody's good. Okay. So the first one we're gonna put 1.67 E. And then it's plus or minus 25. Okay. Go ahead and hit equal to constant. Then hit divide. And then you're going to enter 5.24 EE. And then negative 50. 50. And then okay. Okay, so I'm going to put another one on my screen here. Okay? One more on the screen. So are you guys at home getting this?
I got it, but instead of the 24, I got 21.
You got 21?
Yeah.
Okay, this is what I want you to enter. I want you to enter exactly how I type it up there. Okay? So I'm going to clear it to make it a little more clear. So I'll clean it up. Okay, so you're gonna go ahead and hit this, enter this part the way it is. So 1.67, the button EE plus minus 25. And then you're gonna hit the division. Division button. Then you're gonna type in 5.24 EE plus minus button and then 50. 50. Okay, and then hit the enter button or the equal button. Then tell me what you got.
Okay, yeah, now I got it.
Okay, so I'm gonna write it in scientific notation. Then I want you guys to write it into calculator language, okay? So on your paper, write it into calculator language, and then I want you to enter it to give me the answer. Okay, you guys ready? You see how that works? Okay, so I'm gonna go ahead and erase this one. So 2.475 times 10 to the 24 divided by 6.36 times 10 to the negative 36. Okay? So first, I want you to write it out on your paper in calculator language. Okay? And then I want you to enter in your calculator and give me your answer.
Quick question.
Yep.
How would I enter the negative 36? How would I enter the negative in the calculator?
So you enter the plus minus, and then that makes, it puts a negative on your screen, and then you enter the 36.
Okay, thank you.
Okay, so I'll ask you, what was the answer that you guys got first on the calculator? You haven't done that part? Nope, that's not quite right. Let's see. Yeah. Okay. So this is what you should have entered into your calculator.
You don't have to push the plus or minus unless it's minus.
That's right.
Oh.
Sorry for not telling you that. It's funny because I think it's intuitive, I'm like, oh, they got it, sorry.
What's the difference for this one for not putting the plus minus?
What was that?
What's the difference for like this one for not putting the plus minus?
So you don't have to put the plus minus after the EE because this is a positive here, where this one is a negative. You notice that we do it only when it's a negative.
Okay, so only when it's a negative we put the plus minus.
That's right.
Okay.
So your answer that you should get is 3. Yeah, 0.891 51, and then it should be times 10 to the what? 10 to the 59. That's right. Okay? You guys got it? I know for some of you guys, this is all review. And for some of you guys, this is the first time that you use the calculator to the extent, So we have everybody at every level. So you guys have to bear with me, It goes a little slow. Don't worry about it. When we get everybody to the same page, then we'll start going into 5th gear, and then you guys can be slow down, slow down. Okay? How do you feel about it? You feeling comfortable? You think you guys got it? Yeah? How do you get to? Because that E, when you look at the answer, that E represents 10. Okay? So it's times 10. You understand? So when you guys enter your calculator, this is what you're going to get. So your calculator is going to give you those same numbers, right? So that it's going to give you so when you enter your equal, right? It's going to give you the same number that we have, 3.89151, and then it says E 59, right? So that E59 on your calculator, that represents 10 to the 59. You get it? Okay? And that's important because if you don't include that part, you're not recognizing how big that number is. Okay? So we translate it so we know that E means times 10 to the, and then this is our exponent. So that E represents exponent. Okay? So when we write our answer, we want to write it in scientific notation because not everybody reads computer language or calculator language. Okay? Okay, good. Okay, so you guys got 5. Just 5. That's all you got. I said you only got 5. Say it what? Say it again? Say it louder, because I know that. 5 what? Okay, so this is the important part that you guys need to understand. When you tell me something, you've got to tell me units that go with it. Because I told you guys you just got 5. Does that mean I have 5 hours? Does that mean I have 5 minutes? Does that mean I have 5 days? I just told you had 5. You had no idea what the hell I was talking about. She looked at me, she's like, okay, $5? What? You don't know what it is unless you tell me the units. So when you guys are writing your answers, you have to include those units because it doesn't mean anything to me otherwise. right? So we want to make sure anytime that we're talking about a quantity, it has a value and a unit that is associated with it. You want to always include that unit. You guys have 5 minutes to go take a break, right? Now you guys know how long you have to take a break, right? If I just say 5, you're like, stop, right? Somebody's gonna come back in 5 days. Oscar, that's what I told him. I'm saying you got 5. He's gonna wait 5 days before he comes back. He's here, so I can pick on him, right? This is what happens, you don't show. Okay, so you want to always make sure that you're including your units because it means nothing to us otherwise. So what I want you guys to do is, I want you guys to express 50 minutes in seconds. Okay, so what is my given? What am I starting off with? 50 minutes. What is that equivalency? How many minutes will equal, how many seconds will equal a minute?
60 seconds.
So I know 60 seconds equal 1 minute. Okay, so we talked about the old guy and the new guy, right? We talked about the old guy and the new guy, right? Yeah, I forget, I had so many classes, right? So do you guys remember the old guy goes on bottom, we get rid of the old guy. The new guy goes on top because that's our priority, so we want it in seconds. So in this case, we're just gonna be multiplying across. So we ended up with how many seconds? Okay? Piece of cake, right? Now, the reason why I want you guys to do this, because this is a simple problem. It's not necessary for us to do it, because we already knew that 60 seconds is going to equal to 1 minute. But when you're working with something that is a lot more complicated, which is what you're going to be doing in chemistry, you need to set up your table so that you can sit there and clearly understand and not make a mistake. So let me give you an example. We have 3.5 centuries in minutes. So I want you to express 3.5 centuries in minutes. 3.5 centuries in minutes. Okay? So let's talk about some of the conversions that we need to know. How many years are in a century? Century.
100.
100. So 100 years equals 1 century. Okay? What else do we know? $365 days in a year. What else do we know? 1 day, 24 hours. What else? 1 hour, 60 minutes. Okay? So, what is my starting point? 3.5. Centuries. Okay, so which conversion am I going to use first? Years. So we're going to put years on top. We're going to put years on top. And then centuries. So we're using years and centuries. Okay. Who's going on top? Years or centuries?
Years.
Okay. So we're gonna put that 100 years on top. 1 century on the bottom. Remember real quick. Then, okay, so then I'm gonna use days on top or on bottom.
Days of-
Okay, so 365 days, 1 year on the bottom. And then set, you gotta say it a little bit louder. Okay, 24 hours on top. And 1 day on the bottom. And then 60 minutes on top. And 1 hour on the bottom. So, all we're gonna have to do is multiply 3.5 times 100 times 365 times 24 times 60, right? Because on the bottom we just have 1, 1, 1, 1, right? What do you guys get? Okay, say it one more time.
1,080,000.
Okay, give it to me in scientific notation because I'm special. Okay.
Oh. Sorry.
Well, that's not a scientific notation, that's what.
Okay, so 1.839.
So 1.8396 times 10 to the okay, to the 8. And the units are, what are we left with? Not seconds,
Oh,
minutes. Okay? So if we do that crossing out, make sure that everything matches up. We're left with just minutes. Do you guys agree? Yeah? Anybody disagree? Anybody want to give me cash? Okay, good. So the next thing we need to talk about is significant figures, right? Because we talked about that a little bit, say figs. We talked about it for 2 days, right? So, how many sig figs are we starting out with? 2. So my answer should be 2, okay? So these are conversions. We don't have to worry about the number of sig figs for our conversions, right? Because those are set numbers, we don't have to worry about it. So we start out with how many we started out with. So my final answer, if I'm going to submit an answer for all the points, my answer should be what? 1.8. 1.8 what? So it's going to be 1.8 times 10 to the 8 minutes. Okay? So that will be the answer that we submit. This is the answer that we actually got. Okay? Because we're taking into account significant figures. We started out with how many non-zero numbers? 2, right? Okay? So, you guys got 5 minutes. See, now you have time. 5 minutes, you have a 5-minute break. To go freshen up, step out in the hall, cool off a little bit. Okay, then we'll pick it back up in 5. Do you guys have any questions online?
Yes, real quick. Can you repeat like the last part where you put the 1.8 times 10 8.
So why was it 8? Oh, so why was it 1.8?
Yeah.
Okay, so we've talked about sig figs. You guys haven't had a chance to talk about that yet, but it is in my lecture, and it will be in this lecture. We'll remind you about it here in a minute, but I'll give you the quick rundown. So when you're taking a look at the number that you're starting out with, you want to look at the number of non-zero numbers, or what we call captive zeros. So if it's a 0, and depending on where that 0 is located at, it's going to be considered to be significant, meaning that it's still, all of your numbers are going to be important, but when I talk about significance, certain times we will have numbers that mean more than others, and sometimes we have uncertainty associated with numbers. So let me give you an example. Let's see. So my example here is, so if I weigh myself on a scale, and on one scale that is a really, really good scale, my Richter rating scale, I get 230.17. On my middle class ring, I get 227.1. And then on my poor frame, their scale is really janky. They probably got it at the flea market because they're working on a budget. I get 220. Sorry, I'm showing it. Okay. You see that? There. Let me get a better marker. Okay, so my Rich Friend scale, this first one, this very first scale, that one gave me 230.17. So in this case, all of these numbers are going to be considered significant because this is called a captive zero. This 0 is sure because it's stuck between two numbers. So we're sure about that number because it's stuck between two non-zero numbers. Stuck between these two non-zero numbers. So in this case, we would have end up with 5 significant figures. Okay? The next one, we have 1, 2, 3, 4 non-zero numbers, so all of those are going to be significant. So this guy would be 4 significant figures. And then in this last one, this is 0 here. Okay, so we have 1, 2. The fact that we put a decimal point there tells us that we're really unsure about this 0. This 0 right here, we're not too sure about it. It actually could be 1, or we can end up with 219 or 218. We're not so sure. It was fluctuating, so we didn't take the time to put a decimal point there to let you know that we're sure about it. So in this case, we would only have 2 significant figures. So, since we only have 2 significant figures here, then if we use this as our starting point, we can only have an answer that has 2 significant figures, because that's how much we're sure about. Okay? So, when we did this question up here, we had 1, 2 non-zero numbers that we're starting off with. So our answer has to have 2 significant figures. So in this case, when we ended up with 1.8396, well, this 3, we can't really say anything about it because we only started out with 2 sig figs. So that means we can only use that 1.8. The rest of this, if this 3 was greater than 5, is 3 greater than 5? All right, I'm talking to you. Is 3 greater than 5? I think she answered me, but didn't. Well, 3 isn't greater than 5. So since 3 isn't greater than 5, we're going to just put 1.8. If it was greater than 5, then we would round it up, it would be 1.9. Because we're saying, we know that for sure, it has to be something that's greater than that 5, right? So we're confident enough to sit there and give it that extra boost if it was greater than 5, okay? Does that make sense?
Yes.
Okay, so even if it doesn't, we're gonna talk about it a little bit later to kind of solidify it. And then I'll talk to you guys about it again during your labs, because you guys are gonna make sure you're gonna be using it for your labs. Okay? Okay, so you guys ready? Ready for round 2? Got that fresh air, cooled off a little bit?
We can attend class through our computer if we wanted to.
On Thursday, today's Thursday, right? No, today's Wednesday. You guys are Wednesday. On Wednesday's your lecture. You can technically attend class here via the computer, but you're gonna have to, because you guys are technically supposed to be here face to face, you're gonna have to participate.
Oh,
So these guys are technically in an online class, so their participation is discussions and all these other things, right? So this is like extra for them. So. But it will be recorded and it will be posted, and I'll be trying to post it to your page as well, and I'll show you where that's gonna be at, those links for everything. So, oops, like flipping through everything. Okay, so often we come into cases where we have to do word problems. You're always gonna have to do word problems, or you'll get a problem that you have to think about, right? And so you need to be able to decipher the word problem. The way that I always tell every student to start, you always want to start with begin, okay? Things that are given, okay? So in this case, the problem reads, the oldest horse racing track in the United States is the 8 furlong Pleasantation Fairground Racetrack in California. What is the length of the track in rods? And then it tells us 0.025 furlong is equal to 1 rod. So, what is going to be my starting point? What am I going to start off with? Eight furlongs. Okay. So then what am I going to do next? I want to get to rods. Okay, so am I going to put that on the bottom or am I going to put that on the top? Okay, I'm going to put it on the bottom. Did you say that because I gave you the evil eye? Or did you realize that we need to get rid of the old boyfriend, right? Especially with a name like Furlong. Then what's going on top? Okay, what do you guys end up with? So 320. Okay, so this is what I'm going to ask you. So you're going to end up with 320 as your answer, right? So would that be the answer that you report on an exam? No? Why? How many sig figs do we have here? So So we have one sig figs, yeah. In that case, we have two sig figs, right? Because we have three, yeah. Okay. So then how would I report it as one sig fig? You can do the scientific notation, that'd be one way of doing it, or you could just how could I write 320 so that it's only one significant figure? So what is our significant figure? So yeah, technically you could do this. You could do 3 times 10 to the second power, right? That would be one significant figure. Okay? Or I can write it as just 300. As long as I don't put a decimal there, that's still one significant figure. Okay, so this would be the case with significant figures. Okay? So either of those answers, when we're asking you to take into account significant figures, that was incorrect. Okay? Questions? Yes.
So how would it prevent?
Say it one more time, please.
So, how do we put 300 rocks? How do we put 300?
So the actual value is 320, right? But we started out with how many sig figs initially? That 8 furlong is how many significant figures? 1, right? So since that's our starting point, we have to end our answer. If we're taking significant figures into account, our answer has to be in significant figures. So we need only one significant figure. This is how many significant figures? Over here, it's 320. That's 2 significant figures, right? So in this case, we're using the 0 as placeholders to let us know that it's in that 300 value. Because we only put 8 here, is it really 8? Maybe it's 7.5. Maybe it's 7.55. Maybe it's 7.8. Maybe it's closer to 9, or at 8.2, We don't know, right? We only know about that 8. That's the thing that we're sure about. Everything beyond that, we're not sure about. So we can't sit there and go from something that we're unsure about and expand beyond that. You can only go within the range that you know, right? So if you go beyond that, you're extrapolating, right? And then that can cause some problems, okay? Without having enough data. Okay, you guys ready to move forward? Any questions, concerns, cash money? Okay, so often you're going to be using equivalencies. So equivalencies are basically expressing 2 quantities relative to each other. So like if we talk about your speed limit. So what is the speed limit right in front of a school? 25 miles per hour, right? Give me my units because 25 means what? 25 minutes, right? So it's 25 miles per hour. So we're comparing miles and hours. So that would be an equivalency, right? Conversions. If I'm converting from one unit to the other, they're kind of the same thing as equivalencies, right? So let's say I'm converting from centimeters to inches, right? That would be a conversion, okay? Okay, so write the equivalency and conversion factors for 1 day is 24 hours, and then you want to do my car averages 17 miles per gallon. So how would I write that mathematically? Are there any other ways that I can write? So how could I write that mathematically?
Would it be 1 day over?
Okay, so 1 day, I'm gonna be lazy and just put 1D over 24 HR. Can I write it another way?
Would it be 24 hours over?
That's right. Okay, questions? Straightforward, right? Okay, what about my car averaging 17 miles per gallon? I heard somebody say 17, what? 17 miles over 1 gallon. Okay, what other way? Okay, 1 gallon over 17. Okay, questions? No questions? No concerns? Kool-Aid or cash? She nods with cash. You mean you're giving me cash or you want cash? Oh, okay. Okay. So my algorithm is slightly different than theirs, but here's another alternative way of trying to solve a problem, right? So I always start off with the given. They always start off with the given, right? I always try to figure out what are my conversions, right? So typically my given is typically given to me in a single unit. So it would be 1 unit. It's not something over something, right? That's the way I think of giving in most cases. Occasionally we'll get thrown off, but for the most part it holds up, okay? So your conversions or your equivalencies are always going to be something over something, right? So 17 miles per gallon conversion, right? 24 hours per day, conversion, right? And so we're not going to start off with that. We're going to start off with what's given to us, our starting, okay? So then I always look at it as I want to get rid of the old. So if I want to get rid of the old units go on bottom, the new unit go on top. I always think about switching out that old boyfriend. He wasn't good enough. I want the new guy. He's better. Okay? Or the new girl. They're better. Okay? Questions? Concerns? Okay? So the other thing I'm going to say is make sure you follow your units because your units tell you the truth. If you've gone through it and you've crossed out the units when you're supposed to cross out the units, it'll end up with only the units that you're looking for. If you screwed up, you'll end up with some unit squared because you screwed up. Okay? So calculate the number of weeks in 672 hours. So what are some of the equivalencies I'm going to use for this one? So we have 24 hours equal 1 day. 7 days equal 1 week. Okay? So how would I set it up? What's my given or my starting point? 672 hours. Then I'm going to use okay, so 24 hours on the bottom. Okay. Okay, 1 week on the top. Seven days on the bottom. Okay, so again, these lines here, they mean multiplication. So if we go across, so we have 672 times 1 times 1. Then we're going to divide it by 24. Then we're going to divide it by 7. Okay, so the answer is 4. So how many sig figs did we start off with? 3. So then I need to end up with 3. So I'm going to have to put 4.00. So that we end up with 3 significant figures. Okay, questions, concerns? Cash App. Okay. Any questions online? Are you guys good? Okay, guys ready for the next one? Okay, what distance expressed in miles will an automobile travel in 3 hours at an average speed of 62 miles per hour? Okay, what are we gonna do? What's my starting point? So is that my starting point or is that my conversion? Okay. Okay, 3 hours. Okay. What's next? So 62 miles on top. Then on bottom,
1 hour.
1 hour. So we might answer. So 186 miles. Okay, so here's my question for you. In this case, what would this be the answer that you would give if I'm asking for significant figures? Okay, what if I'm asking for what is the answer if we take into account significant figures? Okay, that's the, so what would be the answer then?
Do we run that or run just like
Okay, how many sig figs do we have? We have one sig fig,
for the final one? But then you only have
we should have one. Okay, so we take a look right here. So that would be my one sig fig. So then we take a look at the number next to it. Let me circle it in a different color. Hopefully. Okay, so we're gonna take a look at that, right? Is that greater than 5? Yeah. So then my answer is gonna be, so it's 200. 200 miles. Okay, so you guys kind of see what sig figs do. They kind of make it like an estimate, right? Because, you know, we said we're going to start off in 3 hours, but I know myself, I say I'm going to start off 3 hours ago, but you know, I stopped here, it was another 15 minutes, it was probably like an hour and 20 minutes before it actually took me, but I tell everybody, oh, it just took me 3 hours. Okay? Okay. Okay, a little girl broke her piggy bank. Inside, she found 2,608 pennies. How many dollars does she have? Okay, so where am I going to start? Okay. So what is the equivalency that we want to use? We want to get to dollars. Okay, so 100 pennies. Is that going to go on top or on bottom? Pennies on the bottom. This Penny's the old boyfriend. We want to get rid of him. We want the dollars, right? Dollars on top. So we have $1 on top. Okay. Cash money, how much does she have? So $26.08. You can almost buy, you can't get gas, full tank of gas. Couple candy bars, what is that, what, 5 candy bars these days? Okay, questions? No questions? Okay, good. Ready for some more? Okay, so we've talked about the metric system. So one of the benefits of the metric system is that it's being used internationally. We often will use it for science. The metric system is also the system that we like to use for SI units. SI units basically means System International. It basically means that, hey, we're all using the same units so that everybody can understand what we're talking about. We know that the metric system is based upon a unit base. So like if we're talking about distance, we're going to use meters as our base. If we're talking about mass, we're going to use grams as our mass. If we're talking about volume, we're going to use liters as our volume. Okay, so we know that it's going to be on a base unit, and from there, we just use factors of 10 to sit there to distinguish the scale that we're working with. Okay. So this is that beautiful scale that I talked to you guys about. You need to be familiar with this, right? So if you guys look at this, we've talked about it yesterday. Deca, hecta, kilo, mega, giga, tera. So these are the values that you'd be multiplying that base unit by to get the comparable amount. So 1 decameter would be 10 meters. 1 hectometer would be 100 meters. 1 kilometer or kilometer will be 1,000 meters. Okay? And 1 megameter would be 1 million meters. And we can go on, right? So, and that's the same thing if we go the other way, right? These are our smaller units, deci. So that would be 1/10. So we're at 0.1. Centi, 0.101. Okay, so 1 centimeter is 0.01. Or we can flip it around and say 1 meter is going to equal 100 centimeters. Okay, so those are the scales you want to be familiar with. Okay, are you guys good? So when we talk about mass and weight are different. Although when we look at them here at the on Earth, we don't look at them as being different. They mean the same thing to us. But the distinction between mass and weight is the gravitational pull or the gravitational force that is being applied. Okay, so if you look at the weight, we would weigh differently on the Earth compared to weight on the Moon, because the gravitational force of the Moon is 1/12 that of the Earth. Okay, so we'd have to divide it by, 1/12 of that of the Earth. So we'd have to divide it by 12 to sit there and get our weight on the Moon. But the mass is going to be the same on either planet. Okay, so mass just represents the measurement of quantity of matter. Okay, so when we think of weight, you say how much you weigh. I weigh 220 pounds. So if I weigh 220 pounds, if it's my weight, right? When I go to the Moon, I weigh 1/12 of that. So I would just divide it by 12, right? But if I said my mass is 100 kilograms, right? And then if I go to the Moon, I'm still 100 kilograms because it just represents the quantity of me. Okay? Does that make sense? So SI units. So SI units for mass, length, and volume. SI units for mass is the kilogram. And so we'll use the kilometer, the kilogram to determine the mass in most cases. For what we're doing, the scales that we're typically doing, we're not going to use the kilogram level. We're going to be using the gram level, right? But a lot of times we'll report things in the kilogram level if we're using things that are comparable to that scale. And so we'll adjust based upon what we're using, right? So if I'm administering a small amount of drug, I'm probably going to be using either milligrams or micrograms, right? I'm not going to give you guys kilograms of drugs, right? Right? Okay. So anytime a doctor prescribes, okay, I'm going to give this person 5 kilograms of ibuprofen, you're going to say what if you're his nurse? So if the doctor has on a prescription slip that he's going to give the patient 5 kilograms per day of ibuprofen, where you're just gonna let him do it, you're like, okay, do whatever you want to do. Right? Kilograms is a lot, right? 5 kilograms, so this is 1 kilogram about, this big. So somebody's taking this big 5 times a day. You're gonna be like, okay, that's fine, right? Go ahead, you go do that. That's what you're gonna say? You're probably gonna say, doctor, did you make a mistake here, right? Because you know that 1 kilogram is about this big, right? So you'd be like, hell no, you're not giving him that, right? You're trying to kill him or what, you know? So you want to be aware of the scale that you're working with, right? If he said 5 milligrams or 5 micrograms, you'd be like, well, I guess I can see that. But 5 kilograms, hell no, that won't work, right? So you have to make those checks and balances, right? So, because you guys don't want, you want to keep your job, right? You don't want his clinic to go out of business, right? So then you need to make sure, and doctors will, they get there, they've been working, you know, shift after shift after shift, and then they try to go out and party at night, you know, it's my wife's anniversary, I'm gonna go take her out wine and dining, and he comes in, his eyes are like this big and everything like that, and he's just writing prescriptions all day, you know, it's like, oh yeah, you get 5 kilograms of this, you get 5 kilograms of that, you know. So you want to make sure that you guys understand those scales, right? Okay, so in terms of distance or length, we're going to use meters, right? So you guys are familiar with the meter? Did we play with the meter stick? I didn't have you guys play with the meter stick. We'll have you guys play with the meter stick. Don't worry about it. That's not next week, but actually it is a little bit next week. Yeah, a little bit next week. And then, so we also, because we're in a lab, we're probably not going to use a meter stick. You guys know a meter stick is about that big, same as a yardstick, right? So if a meter stick is about this big, we're probably not going to use it to sit there and measure, you know, the size of the tablet that we're using, right? Right? Tablet of medication. And we're going to pull out a meter stick, and we whip out this big old meter stick, right? You're probably going to use something like just a little ruler, or, you know, even smaller than that. Calipers, you know, something along those lines. Okay, so in the lab, we're probably going to be using such small distances as centimeters, millimeters, nanometers, things to that extent. Okay, picometers. Okay, so one conversion that you want to remember, and all the other stuff is a little extra, if you guys want extra, is 1 kilogram is going to be equal to 2.2 pounds. So if you guys have your periodic table available, anybody have their periodic table available? If you guys go to that second page, if you guys go down to the very bottom, second page, that's literally the second page, yeah, the back page. So if you go down to that bottom, there it says kilograms, ounces, and pounds. Kilograms, ounces, and pounds. So if you guys look at 1 kilogram, and it says 2.205 pounds. You guys see that? Make sure you guys put that decimal there, because sometimes when I photocopy, the decimal doesn't quite work out the way it's supposed to. So for you guys online, there should be a chemistry packet I'll make sure that it's available. If it's not available, let me know if you guys see it under modules. It's either on the bottom or at the very, very top. If it's not there, let me know, and then I'll get one for you guys. Okay, so you're gonna be able to use this packet on exam. So you have a lot of conversions, so you don't have to remember it, but it doesn't hurt to remember, right? So I also know, like from the back of my head, that 2.54 centimeters will equal 1 inch. So if I have at least one of those conversions that are converting the US customary system, that's basically what we use in the US, to the metric system, I'm able to convert just about anything, right? As long as I know that one thing of that topic, right? I also know that 1 gallon of fluid is going to give me 3.785 liters. And so by me knowing just those three, I've covered distance, I've covered mass, and I've covered volume, right? Because I have those conversions, and once I have those, I can sit there and use them for everything else. Okay? So, here, this is basically just showing us, when we talk about length, we're often going to be converting from the US system to the metric system, right? In the US, we've been so accustomed to using the US system. We use, what do we use for distances? We use some units in the US. We use feet, inches, we use miles, we use yards, right? And just out of curiosity, how many inches equal 1 feet? Okay, so we know that 12 inches equals 1 feet or 1 foot. How many feet equal a yard? 3 feet equal 1 yard. How many yards equal a mile? Nobody remember? 1,760 yards will equal 1 mile, right? So, does it make sense to you? I'm just curious. No, does it make sense how we're going up in that scale? So we're going from inches, 12 inches, 3 feet. Then, does that make sense? Does it seem like there's a nice little pattern going on there? I'm sorry, it don't make sense to me. I don't know how the hell you got from 12 inches to 3 feet. It's just like, how'd you get to 3 for that next level, right? Where if you take a look at the metric system, it's base 10, right? So I know that a deci to a centi, well, that's adding 10 more. From a centi to a milli, that's adding 10 more, right? So I know that, if I wrote down, let me show you what I'm talking about. 12 inches equals 1 foot. 3 feet equals 1 yard. 1,760 yards equals 1 mile. Okay? And then if we go 1 meter equals 10 decimeters. One meter equals 100 centimeters. 1 meter equals 1,000 million. Okay? So, this thing is silent. Is that better? Okay, so if we take a look, the metric system, right? So we put this all based upon the meter. The difference between a centi and a decile is how many? What factor? What do we need to put? 10. The difference between a centi and a milli? Let's see. 1, 2, 3. We're adding 1 0, so that's what? What is 100 divided by 1,000? Or 1,000 divided by 100? It's 10. So it's a factor of 10 difference. So if we take a look, the metric system is a 10 base, right? So it's increasing by factors of 10, right? Which is a lot easier to remember than 12 inches, 3 feet, 1,760 yards, right? It doesn't make sense, right? Because the empirical system was sit there based upon, or US customary system was based upon the empirical system. It was based upon the thumb of the king. That represented the inch, right? So the thickness of his thumb was what an inch was. Okay? And then they said, well, up to his waist, that was a yard, right? And then I don't know how I know they got a mile, you know? It's like maybe it was where he wanted to ride to or something like that, just walk or something. I don't know. I don't know where they are. But 1 mile is based upon something along these same lines. And so it doesn't make sense, right? Where this is more logical. It's factors of 10. It's easier to teach, right? I can teach you factors of 10. 1 times 10 is what? 10, right? 10 times 10 is what? 100. 100 times 10 is what? 1,000, right? So it's really easy to teach, right? But we've chosen the empirical system because that's what we knew. That's what we were comfortable with, right? And if I gave you guys a yardstick, you look at me first off and say, what the hell is this? And if we flip it over and you recognize that it's a, I'm sorry, if I gave you a yardstick, you recognize it. But if I gave you a meter stick, right? You'd be like, what the hell is this? Why is this different than that yard? You do a pretty good job of estimating what a yard is compared to what a meter is. Even though they're comparable, right? They're a little bit different, they're about that much off from each other, right? But you will do better in the empirical system or the US system because that's what you're familiar with. So we're gonna try to mess with your familiarity and get you guys used to the metric system because the metric system is what you're gonna be using in medication, right? You don't give pounds of medicine, you know? You guys give pounds of medicine? Or ounces of medicine, right? Okay? Does that make sense? We give it in grams or milligrams or micrograms. And so you guys need to have an idea of what does that mean, right? So if I ask you, can I get a pint of beer? Right? Could you guys give me a pint of beer without any problems? We're working at a bar, you can guesstimate what a pint is. Oh, yeah, this is about a pint. Oh, that's a pint, right? Yeah? Okay? But if I ask you, I want 500 milliliters of beer. Could you give me 500 milliliters of beer and be confident in it? Milliliters. Sorry, not milliliters. Okay. If I wanted if I want a kiloliter of beer, 1 kiloliter, how much you guys think that is? Okay, if you had a liter soda, a bottle, how much is that? You know what a 2 liter is because we see 2 liter bottles everywhere, right? So think about 2 liter, right? So a liter is going to be about half of that, so it's about so, right? Let's go about a liter, right? Okay, so if I wanted a liter, and then a kiloliter is what? How many times greater than a liter? Well, keep going. Greater than 10. So 1,000, that's right. A kilo is 1,000 liters, right? So a kiloliter is 1,000 liters. Okay? So that means that I'd have a shitload of beer. I'd be drowning in beer. I'd be swimming in beer, right? I could put my pool. Well, not quite my pool, maybe a kiddie pool, you know. A beer, right? Okay? So we need to be able to sit there and think about it. Again, if the doctor tells you, okay, so we're going to give this patient 5 mils of this drug. What is 5 mils? 5 milliliters, right? 5 milliliters of this drug. Now it says the maximum is 500 microliters, right? And you're giving them 500 milliliters, what's gonna happen? Which is bigger, micro or milli? Oh, yeah, milliliters is bigger, that's right, yes. Micrometers is smaller, right? Micro meaning small, right? So micro is 10 to the minus 6, right? 10 to the minus 6 of a meter. Or we could say 10 to the 6 micrometers will equal a meter, where 10 to the third milliliters will equal a meter, right? Milliliters will equal a liter. Okay, so we want to be familiar with the terms and get an idea of which one is bigger and which one is smaller, right? So, questions? Concerns? How many of you guys are familiar with the metric system? Anyone? Anyone? Say, oh yeah, I know the metric system. How many of you guys are familiar with the US system? Most of you guys, yeah? So we're gonna have to break that a little bit, right? Okay, so the other one that we're talking about, the other SI unit that we're using is cubic meters. Cubic meters, because you guys have played with the cube before, so like, this is almost a cube, where the length, the width, and the height are all the same, and we multiply them by each other, that represents that space, that whole volume. Length, length, width, length, and that's it up here. I'll get it. Length, there we go. Width and height. Got it. Okay, take me a minute. Boy, that little break does it to me sometimes. Okay, so but we look at it, this is going to represent that whole space, right? So when we think about the cubic, right, something cubed, we're talking about its volume, okay? Cubic meters, cubic centimeters, cubic inches, cubic feet, okay? So we're talking about the volume that's occupied. Now, when we think about those volumes, right, a lot of times we make volume associated with liquids, right? And it's kind of hard to imagine solid liquid, right, unless we freeze it. So we often will use different instruments, like perhaps a cylinder, to measure those liquid volumes, right? The space is being occupied by that liquid, okay? So this is it's 1,000 milliliters. 1,000 milliliters is equal to what? 1 liter, that's right. So if we bring it up to 1,000 milliliters, this is about a liter of drink, right? A liter of soda. Okay? So you're going to be using liters, milliliters, cubic centimeters, right? You're in the doctor's office, right? Somebody passes out, you're like, "Oh," and the doctor screams, I need 5 cc stat. What are 5 cc's? What does that cc stand for? Crazy Carmen? What was it? Cubic centimeters. So he's saying he needs 5 cubic centimeters of some drug to help this patient, right? Well, a cubic centimeter, 1 cubic centimeter is equal to 1 milliliter. They're comparable, they're equated. So he needs 5 milliliters of drug to help this patient. Okay? So those are volumes. This is just kind of giving you the representation of a milliliter, a cubic centimeter, and then also compared to a liter, right? Relatively speaking, this is relative. Okay? So with the metric system, we always have that base units, right? So we can use grams, we can use liters, we can use meters, right? Those are our base units, right? But we have those prefixes that we use to tell us that scale of that unit, right? So if we know it's kilo, we know that that's going to be 1,000 of that base unit, if it's kilo, right? So a kilometer, kilometer, right? A kiloliter, right? That's 1,000 times greater than a liter, right? If we use the term centi, right? That means that's 100 times less than our base unit. So 100 centimeters will equal 1 liter. 100 centiliters will equal 1 liter. 100 centigrams will equal how many grams? Same thing, 100. But not 100 grams, it'll equal 1 gram. Okay, so centi means that it's 100 times less than our base number, right? So 100 of a centi will equal our base number. Okay, milli, right? Milligrams. Milligrams is how many times less than a gram? What does milli mean in Spanish? 1,000. So then how many times less than a gram is it? 1,000. A millimeter is how many times less than a liter? 1,000, right? So it's 1/1,000. It's that much smaller than, okay? So does that make sense? Okay, how many grams are in 0.711 kilograms? Where are we going to start at? My given? What's my given? So 0.711. And the abbreviation for kilograms is kg. Okay, what is that relationship between kilograms and grams? How many grams will equal 1 kilogram? 1,000. Who's going on bottom? The kilograms. Then we're going to put 1,000 grams on top. How many sig figs should we have? 3? Okay. Piece of cake. Good. Strawberry with chocolate frosting. Best cake ever. Vanilla's okay too. Yes.
Does the same rule apply to how many significant numbers are the first things in the answer?
Yeah.
Okay.
Because we're still using conversions, right? So same thing. Okay, convert 5.25 times 10 to the 5th milligrams to kilograms. Ooh. Okay, where am I going to start at? What's my given? I heard somebody say it. 5.25 times 10 to the fifth. And the units are milligrams. So we're going to use an mg. So we want to get to kilograms. Are there some conversions that we can use along the way? What are some of the conversions we can use? So mil means what again? 1,000. 1,000 milliliters will equal what? 1 meter. So 1,000 milliliters will equal a meter. Sorry. Okay, so then a milligram, right? 1,000 milligrams will equal grams. Talk about the units now. All we're doing is changing the unit, the base, right? So if it was millimeters, 1,000 millimeters equal 1 meter, then 1,000 milligrams is going to equal 1 gram, okay? So we know that 1,000 milligrams equal 1 gram. Okay, so then my milligrams are going to cancel out. Okay, but we want to get to kilograms. So we said earlier, when we were talking about those, I think it was kilograms, right? We were talking about grams and kilograms, right? So then how many grams equal 1 kilogram? 1,000. Okay, so 1,000 grams are going to equal 1 kilogram. Okay, so then our grams are going to cancel out. So if we look at this number, we have 5.25 EE5, right? Divided by 1,000, then divided by another 1,000. What do you guys get? Zero 0.525. That is correct. Okay. Preguntas? Okay. You guys got it? Piece of cake? All good? All done? Okay, next question. A fruit drink is sold in bottles that contain 1,892 milliliters. Express the volume in cubic centimeters and in liters. So what is the equivalency between a cubic centimeter and a milliliter? You better remember. We're just talking about that doctor. 5 cc static. How many milliliters was that? 5. So the relationship between a milliliter and a cubic centimeter is 1 to 1, right? So you have 1,892 milliliters. Abbreviation is ml. We know that the relationship between a cubic centimeter and a milliliter is 1 to 1. So we get the same answer, right? 1 times a number is going to be that number. Okay? So if we have 182 milliliters, how many milliliters are in a liter? Come on, milliliters. 1,000. You guys with me? Anybody in New Mexico? Escape? Yeah, one cubic centimeter is equal to 1 milliliter. Yep, 1 to 1. I put that on my equivalency sheet or the little scale in that packet, so I wouldn't forget it. That's what I would do. That's me. Y'all are grown, you can do anything you want to do. Okay? You guys ready for some more? That's all right. You're gonna get some more because I like it. If I didn't like it, I wouldn't give it. Okay, Sig Figs, you guys already know this. This should be a piece of cake, but we have to do it for the people online. So you guys are gonna help me with this process, right? Okay, so when we're talking about significant figures, again, we're talking about that uncertainty, right? I gave you guys the example of the scale, my rich friend, my poor friend, right? Did I give you guys that example? Okay, so because the equipment that we're gonna be using in real life is not always going to be as good as another place. And if we're taking data from different places, we need to determine how certain we are about the results. We don't like to run out that data because the more data that we typically have, the better our results overall are gonna be, right? But if we start cutting things out because, oh, you know, they're poor folks, they got crappy equipment, we don't want to use any of their data. We start cutting things out, that could also impact our study, right? So we want to make sure that we're using adequate data. Let's say you're working with a patient and you're taking data points and you got a sorry ass nurse, you know, she's so sorry. She don't write everything down completely. You know, she puts down the weight, she puts, oh, they're about 120, right? And then where you're pretty accurate and everything, it's like you put down 125. Okay, so let's do this on the board. Okay, so that sorry nurse, you know, you guys are alternating days. You work one day, she works the other day, or she works a shift, you work a shift, right? So you get her scales, her data and everything like that. So she's weighing a patient, the patient says it's supposed to weigh 120 something, right? And you're monitoring her because she's been losing a lot of weight. She started out 250 pounds, right? She's down to 120, right? According to what she writes. So she's real lazy, she's like, okay, 120, right? And you guys have this really great scale, right? You come in and you're very thorough. I'm gonna be to the point. So she's actually 125.7. Next day, she comes in again. She writes. Okay, so later on that day, you sit there, you weigh her, and you have it at 126.31. Right? And then the next day, she comes in, you know, she's at. So, and then you have her at. Okay, which one are you going to think is more accurate? Which one is going to be more certain? Your readings or her readings? Let me help you out. Her, and this is you. Which one is going to be more certain? You, right? Because you already know she was lazy, right? You saw when she was tired, she didn't like to do anything. She sits back, she'll smoke a cigarette, you know, stuff like that. Every 15 minutes, she's out smoking a cigarette, patient's buzzing and all that stuff. You know she's lazy, right? So you're more prone to believe her results than hers, right? But it was written on the paper, right? And if you're looking at the data, you have to take her stuff in consideration. Are you going to give her stuff as much weight as yours? No, you're going to have uncertainty associated, right? So when you're looking at that uncertainty, that's what that CFA is saying. We're going to take your data into account, but we're going to factor in that uncertainty. But we can't make too much of an assumption because we're using two different systems. You're using the lazy system, her system, and we're using the accurate system, your system. But we're taking both of them, but we need all of those data points. We don't want to throw them out. Okay? So, if you look at this, right, based upon what you guys have been told, we know that when we're talking about significant figures, we're talking about that uncertainty, okay? And so the way that you say something is uncertain is by putting zeros to hold that space. You're not 100% sure. She was lazy, she was still 120. It was probably 123, she was too lazy to look at the lines to make sure that it was 123. She was just being lazy, right? So, in that case, right, we know that in that situation, if there is a zero following, you can call it following zeros, right? So in this case, this guy would not be significant. We only have two significant figures. But if we had something like this, 107, right? This zero is significant. So this one is going to be significant. This one is not. Okay? significant. Okay, so in this case, we have how many significant figures in this number, 120. So we have 2 significant figures. Okay, in this number, your number, how many significant figures do we have? We have 5. In this number, we have 1. In this number, 5. In this number, 2. In this number, and then is in this number. Okay, let me give you one more number. Running out of room. We'll clarify when we got it. Okay, so if I have right, 6. Because I took that extra time, and I know this is you're the only one that answered that, right? Because I took the extra time to put that decimal and those zeros following it, I'm letting you know that those are gonna be important. They're gonna be significant. Because I took extra time. By nature, we are lazy people. Would you guys agree? If you didn't have to get up and go to school to learn chemistry, would you get up and go to school to learn chemistry? Or she just asked me earlier, you mean I don't have to come here for this class? Right? She already told me what she was thinking, right? We are lazy, right? It's just the way we are. And we don't have
a silver for today, that's why.
Oh, okay. I'm just giving you a hard time. I have to give somebody a hard time. Okay? So, by nature, we want to be lazy, right? So we're not going to do anything extra unless we have to. We have that lazy ass girl. She's lazy, right? She's beyond lazy, right? She don't even put the time when the numbers are there. She won't even put them on there, right? That tells us that she's lazy, right? So we're not going to do anything extra unless we absolutely must. She knows that she can get away with that crap. That's why she does it. As soon as her boss comes to her shit and say, you need to be more accurate because you're fucking things up, right? Then she's going to get a little more tight on it. Hopefully, she's going to get fired from the other, right? So the point is that if you put that extra time, it's going to mean something. It means something, right? So we put that extra time, so we know that these are going to be significant, right? We take that decimal, 0, 0, 0, because that's extra time for us to do that. Okay? So, in this case, you got the numbers of significance. So you guys don't mind, you guys understand that, right? So let's do a small number, so where we have some leading zeros, right? All right. Okay, for A, how many sig figs do we got? 3. Okay, so in this case, these zeros are just placeholders. They're letting us know the value of what we're working with. They're being used as placeholders. Kind of like when we have numbers like 2, 20, this 0 is acting as a placeholder, letting us know that value. Okay? Okay, what about B?
4.
Sure. 1, 2, these are extra. Do I have to write these to have the same value? Are they necessary? They have the same value. If I want 0.00021, right? Is it necessary for me to add those zeros? Or is that just extra? We're just letting them know that we're so sure about those, that's extra. So we know that those are going to be significant. So in this case, these guys are all significant. How many say? 5. So we have 5 significant in the case of B. Okay? This here is just letting us know they're placeholders to let us know that it's a small value. Okay? What about here? Say it loud and proud. Come on, don't be scared. 1. So C is 1. What about this last one? How many? 2. So D is 2. Okay? That's sig figs, right? So you always have to think about it. You want to make sure you know the value, right? So you want to make sure you have the zeros to represent the value that you have. Because, okay, anybody got a $10 bill? $10 bill? Come on, pull it out, you got a $10 bill. Anybody got a $1 bill? $1 bill. Okay, we got $1 here. Okay, good, good. $10. Perfect. Okay. So everybody sees $10, $1, right? Okay, I'm gonna write it on the board. $10, $1. Okay? So, how many saved figs does each have? The first one, the $10 bill, $10. And how many saved figs do we have there? We have one saved fig, right? So we have one significant figure, just the one, because the other one is 0, right? So technically, she could have given me $9.99, right? Who knows it's a $10 bill, but that's between us, right? Okay? And then the other one is how many saved figs? 1, okay? So they're both one saved fig, right? So if I give you this, and I give you this, are you happy? You're happy? Yeah? Are you happy? No, you'd be a little pissed off because that was your $10 bill, right? You'd be like, hell no, they're not the same value. Are they the same value? Is $1 and $10 the same value? No. No, it's not. She's like, give me my damn money. You look at her. You can tell this on her face. Give me my money. We'll fight, you know? Okay, so the key is that you want to make sure that you're using the zeros as placeholders to represent the value that they are. If you guys make that mistake in class, this is my money jar. Right here, down here we put some money. For every time you guys make that mistake, I get $1. Right? So if we get an answer and it's supposed to be 1 million and you just give me 1, right? You put $1 in the jar. Okay, you guys see how that works? Okay, so start making money, don't be broke. Start sending your money to pay Dr. Henry. Right? At the end of the semester, we're going to use that for pizza. You guys like pizza, right? It's morning. Maybe we should have pizza. Maybe we should have. I said beers. Yeah, I like beers too, but you know, it's like 8 o'clock in the morning. Beers are a little too early. It's tired. But we'll do pizza. But you guys have to meet me at the bar to have the beer, so you guys have to buy it. So that's the rules. Okay. I think I'm gonna let you guys out a little bit early, right? Because we're just starting that Sig Figs. We'll finish up Sig Figs next week, and then we'll start chapter 2. So you guys are wanting to read chapter 2, and actually you're gonna read chapters 2, chapters. I'll put it on mine. I'll send you guys a message to give you the exact chapters because I can't remember off the top of my head. But chapter 2, definitely. And look over the notes that I handed out. Okay? Are there any questions? Yes.
On the homework, first couple of questions have to do with the chapter.
Yes, I chapters 1 and 3, and we'll finish up next week, which means that you guys are going to get a little bit of an extension on your homework. So it's not going to be this Saturday, it's going to be next Saturday. So I'll be making that adjustment. Yes. You want to read chapter 2. So you want to read chapters 2, and then I'll be emailing you guys about the other chapters, these little bits. Because I think chapter 2 is a combination of the second chapter is a combination of chapter 2, chapters 8, and chapters 1. Yes, yeah, we'll be able to read chapter 2. Alicia downstairs has a drive that has the books on it. So you guys can go downstairs and drive. And then I don't know what I can't after this one. Okay?
So the homework number 2 is not going to be on Saturday.
That's right.
Okay.
Yeah.
Thank you.
Okay. I will see you guys next Monday. Online, are you guys doing okay?
I had a quick question. I was curious to know, if we would be getting a voucher in regards to the kit.
Yes, so to address that, yes, if you had emailed me, well, did you guys do that little quiz that came up? Or the survey, I'm sorry, the survey?
Which survey?
So there's a quiz that came up, it says lab partners and, I believe it says kit itself, lab partner, oh, and alternative times.
I haven't done the quiz yet, but I do have a partner.
Okay, so what you want to do is go ahead and do the quiz, plus you've already emailed me about the voucher, correct? Because I remember
Yes.
seeing your name, yes. So you will be getting the voucher. As I said, I'm just trying to confirm some names in terms of with financial aid and everything like that. And then I will be giving you those vouchers as soon as I get them in my hand. I will be emailing you those vouchers, okay? And then you'll be able to purchase the kit. So don't worry about the delay. The kit should be here in time for you to actually start doing the labs. The very first lab that you guys did, it's going to be done with M&Ms. So you're going to basically just use M&Ms to do that lab. Okay. The
Okay, I
next
did that
lab,
yesterday.
what was that?
The M&M's lab, I did that yesterday.
You did it yesterday? So you're good. You're good to go.
Okay.
So, and then I will get you guys those vouchers. I'm sorry for the delay. There was some miscommunication that happened on earlier on. We were hoping to have them already in hand for you guys, but there was a delay, and so we had to go through this purchasing process to sit there and get that done. So I should have them soon. I'm hoping tomorrow. So I'll be emailing you guys directly tomorrow to actually either give you the vouchers or tell you that it may be delayed another day. But I should have a direct answer for you tomorrow. So,
Perfect. Okay, thank you.
yes, no problem. Any other questions? Okay, so if you guys can also, again, if you take the time to sit there and fill out the that little survey, we're trying to find an alternative time for you guys to go through lectures, so it'll just be you guys and we can communicate if you guys want to do that. The other thing is, I just wanted to make sure that we're lining up with your lab partner. I know you guys have emailed me. I have a lot of emails with lab partners, but I'd like you guys to put it into the Canvas shell if possible. So make sure you guys fill out that survey. It'll take you a minute. Okay? And I have a question for you guys because this class, they had trouble downloading the PDF. Did you guys have trouble downloading the PDF for the book? I guess not. Okay. Are there any other questions? No other questions? Okay. I will see you guys probably next week. Have a good day.